So some of you guys know me from 2600 or Twitter or whatever, GitHub. So I do this for a living. I do this for a hobby. I mess with a lot of Linux stuff, Linux routers, ARM chips, you name it. So, all right. So what is a firewall appliance? What is this USB firewall appliance that I'm trying to do something with? So it's basically a dedicated network security platform with software, with hardware meant to protect users, network devices, endpoints, basically save resources and devices from really bad environments. Protect an internet, protect an infrastructure, enterprise infrastructure. So usually you have your firewall, it does more than just firewall. It would have application data, it will have a proxy, it will have many different services. Instead of having multiple independent, isolated functional units, it will be stored in one location, and it would probably have a failover server for IIS. It would probably have just whatever the enterprise needs. So if it's not IIS, Apache, whatever it is, this is usually mostly for, for customers that have a lot of money. It's not for a small office. It's not for home users. It's not for even mid businesses. It's for something, 500,000 users or higher. This is specialized equipment that is, a firewall, an antivirus, you name it, it's in there. And it's Linux. At the bottom of it, it's Linux with different clients, customizations. Most likely a lot of you guys actually work on this stuff. So basically this is what I was talking about. So this is the firewall management, the central user management for access for the web, for access for verification of downloads and anti-malware and just web protection with proxies, any emails that it might be sending out through MCT, whatever protocol they configure it to be, segmentation, routing, VPN, encryption. It's a very powerful machine. If you look at the right, it talks about quad cores or higher, Xeon processors, or they're usually stacked in a rack away from the users themselves, somewhere in a server room somewhere. But this is not what I'll be talking about today. I'm talking about a portable version of this device for the personal user, for something that's running on ARM, something that's not necessarily as powerful as this. Obviously, you guys have dealt with Linux and played with certain things in Linux where you can see the performance and some of the aggregation of things that you could add within applications and customizations of software. So that's where this talk is really about. So this particular hardware was on eBay. I was looking around, I was poking around, and I was like, well, this is interesting. I've seen a previous version of this. This is some USB device. I knew of a USB version. I spoke with a friend. We got we got a copy of it. We purchased multiple online. We started poking around. I wanted to find out, what is this software that's in here? What's the antivirus? What's the VPN client? Can I mess with it? Can I change it? Can I modify it? Any kind of integration, even the original code, maybe debug a little bit of what's actually happening, if there is some customization. But it has a lot of features. You see it on the right here where it says it has an antivirus, it has spam protection, phishing protection, spyware, intrusion detection, firewall, built-in, proxy, VPN, all in this little tiny ARM, little tiny device. That's pretty cool. I think everybody wants one of these. So if you look at the bottom, the USB version is in the person's hand, and I knew of it because there were other people on GitHub, and in the past, in 2006, 2007, they broke into it. There's vulnerabilities released, there was some information. I knew about it long ago, but this new version was very different. This is probably the last version they created of it, and if you could look at it, it's an Express card, or at least the form factor. So I started poking around, started looking, doing more research into what the original USB version is, and is there perhaps maybe it has the same vulnerabilities. I started looking around. I saw that the operating system that is on there, the version. I started before I even purchased the device, the secondary, the one I just showed you, the Express card version. I started looking around. I said, well, there's a lot of vulnerabilities to a lot of these software. I mean, things have changed since 2007 and 6. I hope they kept it up to date. And if you see the top, the three boxes, one is blue, green, and red, it's mostly the same device with specific software customized to just be sold as a firewall, to just be sold as a antivirus or anti-spyware, and then the blue one is the full, the whole enchilada basically. So, if you can look this thing online. There's you go through the FCC ID, you start poking around. There's people posting things on it. It's been hacked before. I'm not not doing anything new. Nothing's out of the. There's no cat out of the box yet. So I'm interested in the new device because I don't want USB 2. I don't want USB 1. There's obviously a bottleneck. There's a bandwidth bottleneck if I have a gigabit connection or I have some form of really fast internet connection, and this really old device from 2006 or 2007 can't keep up. Can't keep up with my bandwidth. So this is why I don't really want this particular device. So that previous device was actually version 2.0. This is the original version. And this was also hacked early on. They figured out the processor, it was Intel, it was an Intel PCX A270. It was the same processor that was on I don't know if you guys remember the Gumsticks processor, the Gumstick board that they used to sell back then. I've been playing around with ARM for a while, so I don't know if you guys do remember that. But, you could somewhat create your own version, your own homebrew version of this. And some people did. There was a particular seller named Andy, and he used to sell Janus PA, which is basically a version of the original device, but, customized to run Tor, and this is the early days. This is the early days of really slow Tor, basically running whatever you want to run, whatever script, whatever shell script you want, basically your own portable version of this. And this is sort of what I'm looking for, but not for this particular version. Again, this is the original, and this works over I think it's 100 megabits, so it's not really fast. Again, bandwidth problems. I don't want it. It's a really old processor too, early ARM 5 and 6. I'm not interested. So I think I've covered everything here. Okay, so I started looking around, started poking around. I eventually get the card. I started looking at what is actually running in the card. The actual vendor provides the software. At least to some degree, what can be partially running, because what's actually on the device. So, or at least the paid version, not their own custom software. So You can see Snort's there, and they even talk about their own version of Snort. If you could see, I believe that right there they're still being sold on Amazon. It was just me trying to get more, but the idea is really just trying to find out if this is really Express Card or if this is USB 2.0. And there were no real documentation. I couldn't find anything about the driver. I couldn't really find, most of the stuff is really old. I'm trying to poke around, trying to debug something, trying to see where I could start. And then I opened it. I took it apart, and you can see it from the bottom slide there that I discovered that it's really not USB 2.0. It's really not Express Card. It's USB 2.0. And it's a USB 2.0 in a weird form factor. I got really pissed off. I said, all right, this hardware sucks. I really don't want this. But I'm still interested. I still want to see what's inside. This probably hasn't been hacked. This probably hasn't been open. What's inside? What's going on? And why is it, it's this form factor? It's just so weird. I get more information on the previous Yogi, the Yogi USB 2.0, and as I started looking at the NDIS driver for Windows. It works on Linux as well. If you do a virtual driver, it has its own specific application. It's pretty interesting. It creates a network just by connecting the USB through your machine, just like most OTG. USB on-the-go devices nowadays. That are, if you plug your phone to your network or to your computer and set it on network, for Android or wherever it is, it would basically do the same thing. So what I ended up doing, I modified the card, connected USB 2 to it, and I got it working on machines that don't have Express Card. So you guys can see. So I plugged in a jack to it, started poking around. So started looking more into the software, what's actually happening, what are some of the software that's installed. They're using open source, a lot of open source stuff that is provided. They have an open source package that you could download if you buy a particular version of the device. You see pictures on the bottom there of me opening the device. Let's go into that. This is the processor for the device. It's an old Freescale ARM6 processor. So it's a better view of the card, somewhat of my mess of me wiring this USB plug to it, and just a better view of the card. But you can see the USB OTG, and this is what makes this. Again, this is on the go, USB on the go. And this is what makes this particular model work the way it does, where you plug it into your computer and it becomes a network card instantly. So I start poking around. I see the vulnerabilities for the older version, the second version, which is, you can see it on the bottom, application 1, application 2, which is the Pico, and then the Pico Pro. And it's pretty interesting. Remote execution through its own shell, through its own URL encoding, through CGI. So this is the interface. This is where the configuration happens. This is where the vulnerability is. And it's been documented on the previous version. It's pretty interesting. So one of the things I want to say is this device, when in its day, it was supposed to be updated by the manufacturer. So the manufacturer would keep updating your device and will keep it up to date, and it will push the update anytime it went online. The manufacturer is no longer around. They're around, but they're not. So it's not going to receive an update. When you purchase, if you purchase this device, this is going to be probably the first version of this, and it's probably vulnerable one. So I was testing this firmware to that of the firmware that was on a USB version. It's just still, they're both USB, they're both the same thing. So for a lot of people, I guess this is more of the interesting meat of the talk. It's really shell execution. So I started triggering. I made a couple of scripts. I started playing around with just Linux shell and BusyBox because that's what's running on this particular machine. So I started sending these particular commands, these Linux shell commands. So asterisk, the guest sign, mostly all the redirect IO, and if you know about Linux, you could run multiple commands at once. You could send special characters that would trigger particular behavior within the operating system, and if the CGI bin actually allows it to go through, it would cause some serious havoc on the back end, on the server. I mean, this happens today on a lot of servers. If the programmer doesn't cache the stuff, it doesn't do a lot of just testing, and and this is for Perl. I mean, this is CGI bin, but we're still having this problem today for Perl and all these other languages where you have to create a filter to kind of block special characters or meta characters to go through the web portal so that it doesn't get parsed, it doesn't get executed, and it doesn't trigger the remote execution. So this is really what the talk was about. I started poking around. Through my script, I found multiple validations that it actually worked, that I was able to get in. So I was able to get in. I want to do a live demo of what it looks like. So this is Windows. I do apologize. So this is a device. So you could turn it on and off. What it really does, it takes your traffic and it sends it directly to the card, and sort of the card starts listening to everything you do, and it goes from, it creates, I'll show you. The minute you plug it into your computer, it creates a private network. It's similar to Poison Tab from Sammy Kamkar. I don't know if you guys are familiar with that, but non-malicious. This is the protective version of it. Plug it on the other side. Okay. I had it disabled before. So here's some of my history. So what I wanted to show you first was what happens when you plug it in. So when you plug it in, you see the connection as USB 2.0. It's at almost its maximum speed. And so here's the MAC address of a card. Here is the IP address that is given it to, and this is the IP address of the little tiny device. Oh, it's like the, so there is the portal for it. I had logged in before, but this is how it looks like. It might ask me for credentials. That's probably why it failed. But this is why I didn't really want that device. So this is really not, something that I really wanted. So here it gives you more information about what the device is like, what the processor is, its serial number. And then this is the diagnostic portion of what I was saying, where you are able to run your own commands. So I will open this separately. I don't want to spend too much time since this is a demo, and I don't have that much time. The idea is basically you go here, you go to diagnostic, you provide an IP address, and it sends you to wherever. It's really not. This device is not really what I want to show. I created a simulation of this. I created a better version of this, and I've created different versions of this particular device in different platforms. So I took a look. I took a gander at the device, and I'll show you. I created a script. I'll show you. Hopefully, still open on the previous window here. Okay. Sorry, switched from Firefox to Chrome. But anyways, I created a way where, good. That's how old this device is. It's not true. So there, I'm on the device. Again, if you eventually get in there, I created a way to bypass this whole system. This system is really archaic, it's really old, there's a lot of limitations. And I wanted to speak about some of the limitations. They did harden the device enough that if you try to input some of those meta characters that I mentioned before, it would understand, hey, you're a hacker. You're trying to do something that a regular user wouldn't do, and I'm going to either lock the machine. If you do it a certain amount of times, then eventually you could kill this little device. But it has this, it does have a kill switch. For other things inside internally. But anyways, I created a script, and from that script, hopefully I'll be able to show you. Okay, perfect. So this is what that ping command looked like if you go directly to the CGI bin for it. So you see here, I've added the special character %0A echo %09, and then an HTTP request or a SEP header that allows me to run execution from the device. This is the file that I entered on the device. I'll switch over to my script because this is kind of slow. That's why I created my own script, because it's verifying every command you send, and it takes forever, but you can see it right there. This is the original script, and it kind of looks like, ooh. Sorry. Yeah, it kind of looks a little different in this. So. Okay, so there it is. So this is my script. So if you can see here, I've taken whatever input's coming from the HTTP request, and I'm saving it to a file. If you can see it there, I'm saving it to a file, and it's in that file is dumping both the both my basically shell input, but also the error and the return of an echo, basically of the output of the shell, the standard output. So I will give it a command other than what I just gave it. So the device is running as root natively. Gets it in show. I'll just show you from here. So that's everything that's running. And basically I have full access to the device, and I could see it, I could look at all the script, and I could look, that's me right there, obviously, that I hacked. But there's a lot of firewall rules. You basically, Bob's your uncle here, you could basically do whatever you want. It has port knocking, it has snort, it has different versions of this, really old archaic box, busy box implementation. And again, this is kind of, this is really not what the talk is about. So I wanted to create something very much like this. I wanted to create something that's customized and personalized for myself, that I could run basically snort. I could run some of the devices that are running on here. I could run my own antivirus, my own anti-spoofing, and plug it to my device. And I said, well, why, it's 2018. Like, there's tons of ARM devices that could do this. Okay, so I modified a Raspberry Pi to do basically the same idea of what this device is doing. And so I mentioned before, I used the Sammy Camcar's hack. Instead of creating my own NDIS driver to create a USB portable card, I basically just dump all the traffic directly to the Raspberry Pi, and my traffic gets analyzed. I could send my traffic to Tor. It communicates through the Wi-Fi access or whatever Wi-Fi card I want to put in there. So if I want to get something higher end, more powerful, I could definitely get better reception. I could do a lot more than that little card was doing. This is quad core, it's ARM 7, and this is in fact ARM 8 for the latest Raspberry Pi that has a higher clock and better performance overall. But I implemented, and I'm trying to create an operating system for it. And that's one of the things I wanted to get it done before the talk, and I couldn't get it. I couldn't get everything in there. But it's basically the same idea of what this device is doing. And then I said, why stop at a Raspberry Pi? At first I had some limitations. I had to remove the Raspberry Pi's hub, which it's a pain in the butt. You can see it here. So this is basically the lighting is from a light source in the back of the Raspberry Pi, and I created the same thing. I plugged a USB connection to it, mini USB. So I had to find a tracing for the Raspberry Pi to bypass the hub to eventually incorporate whatever Wi-Fi access I wanted to put in there, or whatever card or whatever device. And so here, when you see the logo for the Raspberry Pi, that's actually where it's basically marked for you. So the two dots right on top of the Raspberry Pi logo, it's the hub. And here you will see J3 is basically the opposite side, going directly straight to the CPU. You'll probably see it in the next slide. But the whole idea is, well, I could do it with a Raspberry Pi, but I could also do it with a Raspberry Pi W. It is more portable, it has less processing power, but it's the same idea. Eventually, I kept going. This is some of the slides from the presentation before. But eventually, I went into, USB 3. And I said, well, I want higher performance. I want, better bandwidth. And I mean, I kind of got there. So this is the ROS64. This is it has USB 3. It's probably one of the cheapest models that exist today that you could buy, maybe less than $40 on Amazon. And it would have allowed you to do the same thing. One of the things that I came across was the OTG goes from USB 2 or from USB 3 to USB 2. So then I realized, well, my bandwidth is being limited, So I went further, and I started messing around with the Tegra X1, which is inside the. This is how you get a regular. By the way, this is how you. When you go from a micro to a regular USB, this is how you implement the Wi-Fi card. But this is only working on USB 2. But as I was saying, I eventually went into the Shield, and from the Shield, I was able to run my own version of Linux with my own OTG, basically USB on the go, and I was able to do the same thing. I was able to do it on Android with a rooted Android to eventually jailbreak the device, to potentially do it on another device. And I was looking for another version of a cheaper version because an NVIDIA Shield is about $179 device. I eventually found something much better. I found something called the Arcade 3399. In the 3399, I have to find that. Okay, that's what they are. Again, sorry, it's Windows, sorry for my slides. So they have their own Linux distro, and you could compile it and basically use this particular device to create the same thing. This is what's inside the device. So it's USB 3, the same capabilities, under $100. You could attach it to the back of your computer to eventually do the same thing. It has built-in Wi-Fi. It has the same capabilities that the NVIDIA Shield that T1 would have. So I kept looking. There's a development board from China. It's just as cheap as this particular device. But the idea is to basically get you to start thinking. So there's a lot of customizations. There's a lot of things that happen with ARM and USB 3 and devices that are able to basically do on the go with USB 3. And it's very powerful. You could create your own network, your own private firewall, your antivirus protection, all in a separate machine than the one that you're running. For example, this Windows machine, and be constantly protected. You don't, an attacker will have to bypass and attack that original device, the one that's connected to the Wi-Fi, that's giving you access and is routing your traffic, and most likely is going through Tor or is going through whatever script you want to create. And this is why I want to create an operating system to eventually, harness the power of a particular chip or a particular firmware, and basically put it out there as a product. It's something that you could use and you could create something with and play with. It becomes more like a platform similar to an Arduino or even the Raspberry Pi that you see here. And that's the idea. That's sort of creating something in the middle that is doing all the communication for you, is protecting you at the same time, and is filtering you from viruses, from phishing, from spying, from any kind of attacks, any kind of vectors that could attack your particular Windows machine or Linux machine or whatever is on the other side. And you could attach this to a router. through the same OTG and have a secondary point of vector, so that if they're doing, on the public side, on the internet side, if they're doing just basically an identity of what device is actually connected to the internet, they'll have to really go through certain loops to try to get to attack that particular router. So that's basically the concept. You could create your own high-end network appliance running on somewhat high-end equipment in 2018 and be completely to the point where an attacker might not know what you're actually using. If this is a Windows device, or you could hide the ports, you could even implement a honeypot right on the actual device, and most likely no one will be the wiser. So one of the things that I'm trying to do is to create a form of standardization. There's a lot of problems with the processors and certain Linux libraries. They're not available for certain processors that haven't been ported over to ARM, issues with compatibility, just all around just Linux problems that I'm trying to provide a distro, and basically you'll be the first ones to basically know that I'm creating something like this. I don't know if others are working on something similar to this, but it's a starting point. It's a platform, that could become the next Pineapple, from Hack5, or something better. I mean, you could think of it. Well, the Pineapple is probably doing the same thing or something similar to Wi-Fi. Why wouldn't it do that to protect you instead of attack? Instead of using it as an attack vector, why not use it as a form of protection, a form of putting something in between you and the internet and the rest of all these other attack vectors that are out there. So, that's my idea. Poke around, find out what's out there, find out if you could create your own version of this, and get your feelers out. This is what I'm working on right now. This is the NVIDIA Shield with the Tegra processor. The Tegra processor is probably one of the fastest ARM devices in the market right now. There's nothing as powerful as this device. It has 24 GPU cores. It has eight ARM cores on its own, 4 that are specifically accessible to you, and then another 4 that are not, that are basically big brother or big little configuration, not big brother. So this is what the Tegra development board looks like, and this is a little more expensive. This is about $500 to start play around with it, but it's very capable. It's a very powerful machine. It could make a really powerful tablet. I know Google made a tablet based out of this, and obviously the Shield, not the Shield, the Switch, the Nintendo Switch is running on this platform. So they've shown different vulnerabilities and different attacks to try to bypass the bootloader for the Nintendo Shield version of this, and you could eventually turn your Nintendo Shield into one of these devices that I mentioned. So that's basically my goal. If you already own something, if you already have the hardware, if you already are playing with ARM devices, if you're already playing with Linux, and you already have the capabilities of programming and creating something new, this is basically what I want to get that started. I want to start with perhaps working with people, creating a platform, creating a way to kind of work on this together, to kind of get your hands dirty and get some serious collaboration. I mean, you could create some serious protection, for yourself. Forget about the rest of the world. I mean, eventually it could trickle down. But for yourself, you could create even attack vectors from it by creating a form of protection. This is a very powerful Linux machine. The NVIDIA community has a huge following behind this. There's development boards, as I just showed you. There's a particular distro specifically for the Tegra X1. This machine is very, very powerful, and this is where I want to create the distro. I want to start with this because this is the higher end, and kind of go down from there. And it's a very capable, not just for protection, but you could use the encryption, or you could use the GPU to do cracking, to do password cracking while you're searching the web. You could do crypto mining as well. It's a very powerful machine that you could adapt it to pretty much anything. I have it on me here. It's not bigger than my hand. It has two USB 3 ports that allow you to plug in whatever device you want, and it has the on the go. It's a portable computer. I mean, you could attach this to the back of your laptop with a USB 3 cable, and no one would know. No one would be the wiser. No one would know what you're doing and why it's there. And again, it has the same Wi-Fi capabilities. It could connect on your behalf. It could create a private network between you and your computer, and send your traffic. Send your traffic through Tor automatically through a separate device instead of using your machine. It's a great platform. I hope you guys got something from this, or you could start working on this and perhaps help me create something or create something for yourself. I will be putting the distro on GitHub after the talk. It's private right now, but basically just to show you some of the problems and just some of the debugging, perhaps you could start a small community similar to the DDWRT or OpenWRT when a lot of these devices first came to the surface. That's basically my talk. You guys have any questions?
What's the power draw you're seeing? Is it getting powered from the laptop over USB then?
Well, it depends on the device. So the Arcade 3399 that I mentioned, the second cheapest version of this, it could draw from your device. But it depends on the laptop. So if you have one of the newer laptops that could provide the higher USB 3 power, it will provide it. It will provide the higher end power. It's basically power and data through one cable, and you're good to go. Any other questions? The OS is really tiny. It's about the size of a busy box or something to that extent. Hey.
I had a question. If this is the same target as the Asus Tinkerboard, or the same?
The Asus Tinkerboard is using the ROC64, the one I mentioned before, and that OTG goes from USB 3 to USB 2, and it's just part of the manufacturer. They build a cheaper chip that could basically do the same as the one I mentioned, but is a lesser of its kind. It's not the same. It doesn't work. It doesn't have the same function. So yeah, the Tinkerbox has a similar chip, but not that one. It has the ROC64, that board that I mentioned, that I purchased, that basically let me down.
So in terms of issues with OpenWRT, DDWRT, I know that the community, the OpenWRT community, is struggling to get the Asus Tinkerboard and probably the Firefly here integrated.
The Firefly, it's the same chip, but it's configured in a whole different way. The configuration is very different from the ROC64, from the Tinkerboard. It's in such a way that you need a special U-boot configuration for that particular board, and there's not a lot of support. There's things made out of China. The guys in China are probably taking their time kind of importing some of the things that the ROC chip has created on their. You're better off compiling your own kernel from ROC chip and implementing all the patches that could make this work for you. But yeah.
Thank you.
Yeah. All right, that's it. Have a good one. Thank you. Thank you, guys.